All right, so I'm going to talk about a couple of soft glue modules, 4 in particular, and then I'm going to do some demos of whatever you guys want to see after that. Well, so also some of the stuff that I want to do. I'll do some of those demos too. So first is Autosave. I really don't need to tell anybody here what Autosave does. It saves all the values of selected Epix PVs to a file. It restores those values when the IOC reboots. I'm talking for the people at home, okay? Please don't be offended when I repeat stuff you've known for 20 years. It's not an archiver. It only saves the most recent values of those PVs. And it saves an entire list of PVs whenever any of those PVs change, whenever it writes anything. It can't write just a piece of a list. It's not like a database. And the way it works normally is that each IOC saves and restores its own PVs. It can save and restore any scalar or array valued PV, but some PVs, DBF menu PVs and enum PVs, it doesn't save the string, it just saves the number. So you have to be careful if those strings change in between reboots. It's implemented with 3 different kinds of access to the database. The save operation uses channel access. Autosave just puts a monitor on all the PVs. The restore uses static database access, which is just like typing something into a database file before it gets loaded. The manual restore uses channel access because that's the only way to write after, well, there's also database access. Manual restore uses channel access, so it's not going to be the same as boot time restore because channel access can cause records to process. So at boot time, if you restore the value of a motor record, if you restore the valve field of the motor record, you'll change the value. If you do that at runtime, you'll move the motor. But there is an exception. Arrays are saved and restored with the database access, runtime database access in every case. They have to be restored with runtime database access because arrays don't exist in static database access. So there are 3 restore options at boot time. You can either restore before record init, or after record init, or both before and after record init. And to cut to the chase, basically all PVs are restored at both times. It's not a problem to restore something at a time when it won't work, but all PVs except for motor positions are restored both before and after record init. And the reason you don't want to do this with motors is because motor controllers are likely to already have their value, the valve field, or they're already likely to have the motor's position stored in hardware somewhere. And you'd like to take advantage of that. So Autosave restores before record init, and then the motor record can decide whether or not to use that value or use the value stored in the hardware. And you don't want Autosave to restore afterwards and undo all of that work. But for other kinds of PVs, you can't restore arrays before record init because there's no space to put them. And you can't restore DBF no access PVs because we don't even know what the field type is yet. After record initialization, you can't restore link fields because part of record initialization is to connect those link fields. Well, you could actually restore at that time, but it would be a problem if you did because you would undo the link wouldn't connect. So Autosave basically tries to take all of that stuff out and just restores things that can be restored before and things that can be restored after, and it doesn't regard it as an error if you tell it to do something that can't be done. So some features of Autosaves, the list that tells Autosave what to save normally is just a list of PV names, as you'll see on the next slide, but it can also include files. And this is pretty handy because if you, for example, upgrade to a new version of the motor and the PVs that need to be saved and restored are different in that version of the motor, you would have to go through your autosettings.rec file and change that every motor you have, and there might be 100 motors. So it's much better to have the Autosave request files actually in the modules along with the databases. There are choices of save triggers. Oh, and by the way, you can also override that because there is a path. Autosave has a path that it uses to look for request files, and as soon as it finds it, it stops looking. So if you put your stuff up at the top of the path, then your stuff is going to override anything that's below it with the same name. So the save triggers that Autosave uses are the following. On the change of any PV, and you specify this by issuing the command create monitor set in your startup file. And this is what we always do. This is almost the only thing that we always do. This is how the settings and the positions files are maintained. But you can also save periodically. You could tell Autosave to save something every hour, every 3 days or whatever. You can trigger Autosave to write a file specifying a change of a trigger PV by writing to that PV. And you can also specify the file name if you want, and the file path for that matter. And the last one is manually, which is almost never used. A couple of people have done this. Whoops. A couple of people have done this, but manually now is mostly used by config menu, which I'll show you later near the end of the talk. You can also reload save sets manually. You don't have to, if you've got a save set and you edit it, you don't have to reboot the IOC. You can just reload that. On VxWorks, Autosave can recover from a file server reboot. For Linux, we don't have this ability. Okay, so Autosave can recover from a file server reboot. And what happens is, while Autosave is writing a file, if the file server reboots, it's going to be left with a stale file handle. And that stopped us for a couple of years until we figured out how to have Autosave manage its own NFS mount. So what happens is, if Autosave notices that enough read-write errors have occurred, it will take the mount down and remount it. This only happens on VxWorks and RTEMS. On Linux, it's the system administrator's job to make sure that everything comes back after a file server reboots. So there are other choices. You can choose to save recent copies of a save file. So, for example, if you want a few days history every 3 hours of. So, and the last thing is Autosave reports the status via Epix PV. So, there in the status button, you can find out whether Autosave is still working, when was the last save file, how many save sets are currently being used, stuff like that. So the file format is just really extremely simple. It's just the name of a PV. It's a list of PV names. And here on top I have the list of a scalar PV and an array PV, and I'll show you what those guys look like in the save file. But you can also have this syntax where you specify that a file be loaded and you give the name of the request file, and it also consists of PVs and file commands just like this. So you can have nested file commands. But for these, you normally also have to specify macros. For example, if this really is the motor settings file, there's probably 40 motors in the IOC. And so each one of those gets loaded with the motor database and parameterized with the prefix and the name of that motor, and you need the same thing in the auto settings file. So this is what the save file looks like. The name of the PV and the value for scalars, that's all it is. And for an array, it looks like this. There's this @array marker instead of a scalar value, and then there's a whole list of PVs. There's no number of how many, there's just a list or of values. And these guys resulted from the motor settings.rec file. And there's a whole bunch of those guys. I'm not going to show them all. And one important thing is that the save file has to end like this. Oops, I can't highlight anything. It has to end like this. Otherwise, Autosave assumes that the crate or the IOC crashed while the save file was being written. And it doesn't restore that file. It'll look for the backup file or for one of the sequence files until it finds a file that does end that way, and then it knows that that file was written to completion. So this command, file motor settings.rec, presumes Autosave knows where that file might be found, and you have to specify a list of paths. And typically it's one path for every module. There's the calc module has its path, and the motors and the optics and all that. And Synapse comes with all of these paths filled out for all of the Synapse modules, but if you have another module that you're using and it has Autosave request files in it, then you have to do this by hand. So examples of what that might look like on the IOC shell, which pretty soon will be the only shell we use, right, Keenan? I hope. And the VxWorks shell does things a little bit differently because it can't do it can't do variable substitution. This is actually the string. It's not right. So anyway, those things come from env paths and cd commands, respectively. So if an IOC gets in trouble and Autosave crashes or the task gets suspended or something like that, you can still bail yourself out by running AES-Verify on a workstation. And you give it the name of an autosave file that that autosave should have been writing, and it'll look at all the PVs in there and look at all the save values, and then it'll make channel access connections to all the PVs in the IOC and see whether they're the same. And if they're not the same, it'll tell you. And if they're not the same, probably what you want to do is write a restore file and then reboot the crate using that restore file. And AES-Verify is pretty slow if the file is very long, because it only makes one channel access connection at a time. Because the idea is that if you're using this, the crate's probably in trouble, right? It might be low on memory, or there might be some other problem. So AES-Verify tries to tread as lightly as it can, and that means it's really slow. Relatively new in Autosave is config menu, which, as I mentioned before, is a way of manually saving and restoring autosave files. But they don't have the normal .save suffix. They have .cfg instead, so that it's easier to find them. And also so it's possible to change the file format. The CFG and save files are actually identical, almost identical. CFG files can have macros in them, and save files have to be fully resolved. So config menu knows how to search the autosave directory for all of these files, and it can populate a list of these things, and that's what it normally does at boot time. If you load a config menu instance called scan1, then config menu will search for files that fit this pattern, and when it finds them, it'll shove them into these menus. These are MBBO menus. Shove them into these menu PVs. And you actually can tell it to research that list anytime you want. It's on a bigger display, not the one I'm showing here. So the load operation is just a manual restore followed by AES-Verify. And in this case, AES-Verify is extremely quick because it's inside the IOC. There's no actual channel access connections being made. Inside an IOC, what looks like a channel access put actually gets short-circuited into almost a database put. So we can restore, for example, you'll see, we can restore all of a soft lead circuit in about 1/3 of a second. And because this is just a manual restore, the load files can contain any PVs. They don't have to have the same sets of PVs. So if you're running a read-only instance of config menu, you can specify one save set to set up scan records, another save set to set up user calcs, or whatever else you want to do. If you're going to save, it's different, because save is directed by an autosave request file. And that means every save is going to save exactly the same PVs. So normally, the way config menu is originally intended to work, it can do both loads and saves, and that means that the load files are all going to have the same PVs, but they just will have different values. And another thing that will eventually become important is that the load and save are protected by busy records. They will send a callback when they're done, because these are fairly lengthy operations. I mean, 1/3 of a second in the case of a restore, for example, or a load. And the save might take longer than that. Oh, I don't know how long saves take. So if you write to this with a CA put callback, you'll get a callback after all the dust has settled. And then you'll have to check this PV up here, come on, to see whether or not the restore actually succeeded. So channel access clients can use config menu. That's one of the intended uses, is for a channel access client that intends to direct an experiment to make sure that the entire IOC is set up in a way that's going to be compatible, that's consistent with how that client was written in the first place. Right? Otherwise, the client has to write to everything every time, because it doesn't know what's the current state of the scan records. Are they in relative mode or absolute mode, for example, those kinds of things. If a soft glue circuit is required for the running of this experiment, has it been loaded? So clients can make sure all this stuff happens. And clients include, the command line or Python. You can do an epic CA put with a, oops, I tried to highlight again. this wait equals true stuff, it will wait for the callback after it does that before going on to the rest of the stuff. A string sequence record can do this. Can specify the kind of fly scan that it wants and write to this PV and wait for all those PVs to be written. The most recent capability in Autosave is called Autosave Build, and it allows you to write your auto settings and auto positions files automatically. And what it does is Andrew Johnson modified dbload records so that it had a hook, so that you could specify that whenever dbload records is called, a user-specified function gets called with the same information that dbload records received. And Autosave Build uses that. Recent versions of base have that, and I've modified at least one version of base on APS to patch it, on APS Share to patch it to have this capability. So when dbload records is called like this, with something that ends in .db, it strips off the .db and it adds an underscore settings.rec, and then it adds this file to the auto settings file. Or in this case, we're actually going to add it to the built settings file. So it's enabled with this, Autosave Build, and then you tell it the file you want it to make. This could be auto settings if you really want to go for it. And then you tell it the string that's going to replace .db, and it's also replace .template and .vdb, and the other, I think those are the only options. And then a 1 if you want to start doing it, and a 0 if you want to stop doing it temporarily. You might not want to, it might be that the auto settings file you actually have doesn't end with underscores, or the rec file you have doesn't end in underscore settings.rec, it just ends in .rec. So you can change the suffix and you can enable and disable those. And then after you've built this file, if you want to include it in autosettings.rec, you just add this file, add this command to autosettings.rec. You can also add individual PVs by doing this. So append to file, built setting, and this works for any file. This isn't just about Autosave. To any file you can append any string.